Welcome. Today we discuss some other problems on the chapter Definite Integral. It is part 4 of that chapter. So our first problem is the find the integral of that minus pi by 2 to pi plus pi by 2 uh, x cube plus x cos x plus 10 to the power 5x plus 1 dx. The value of that, the options are 0, 2 by pi, 2 pi, and pi. The problem is given in that year. West Bengal Joint Entrance Examination 2009. Here you see the limits are symmetric, minus pi by 2 plus pi by 2. And you see the integrand, it is x cube. Only this part is odd function. X cos x. X is odd function, cos x is even function. Their product is odd function. This is again a odd function, and this one is neither odd nor even. So let us break into that, the integration into that way. Minus pi by 2 plus pi by 2 x cube plus x cos x plus 10 to the power 5x. The odd function part, this part is odd function. I take this separately, this is pi by 2 plus the remaining one is 1 into dx minus pi by 2 to plus pi by 2. Now, as because this is odd function of x, interval is symmetric, this is simply 0 plus this one is minus pi by 2 plus pi by 2. So actually it is actually 1 dx, it is even function. So this can be written as 2 times 0 to pi by 2 dx. So that 2 into x, 0 to pi by 2. So that it is equal to 2 into pi by 2, 2 into pi by 2, that is pi. So this is correct option. Next. Next one is 0 to pi, integration 0 to pi square root of 1 minus sin x dx. Options are root 2, 4 into root 2 minus 1, 4 into root 2, 4 into root 2 plus 1. And the problem is given in West Bengal Joint Entrance Examination in the year 2014. This one can be written as 0 to pi square root of 1 can be written as sin square x by 2 plus cos square x by 2, and this can be written as minus 2 sin x by 2 cos x by 2. So it is equal to sin square x by 2 plus cos square x by 2 minus 2 sin x by 2 cos x by 2 dx. So that you see it is a perfect square. This one from this to that, it is a perfect square, and it is actually either sin x by 2 minus cos x by 2 whole square, or cos x by 2 minus sin x by 2 whole square. Now, and this whole square, this function is within square root. When we take this one outside the square root, we have to take the positive value. The limit of the range of x is from 0 to pi by 2. Now, we know that this is 0 when x by 2 is equal to pi by x by 2 is equal to pi by 4. That is, when x is equal to pi by 2, this is 1 by root 2, this is 1 by root 2, so it becomes 0. This becomes 0. Before that, when x is equal to pi by 2, before that, this is cos x by 2 is greater than sin x by 2. And after that, sin x by 2 is greater than cos x by 2. So I can write this as 0 to pi, and mind that we have to take the positive value. That is, we have to take sin x by 2 minus cos x by 2, its modulus, a whole square, and square root is that dx. So we have to take the positive value. But in that range, it is actually from 0 to pi by 4. In this case, cos x by 2 is greater than that. So here we have to take cos x by 2 minus sin x by 2 dx plus pi by 4 to, not pi by 4, this is up to pi by 2, because x by 2 is there, it is pi by 2. Now from pi by 2 to pi, in that case, sin x by 2 is more than that, it is positive. So sin x by 2 minus cos of x by 2 dx. Now integration is extremely simple. Its integration is sin x by 2, 2 into that by half minus sin x by 2, its integration is minus another minus cos x by 2 by half, that is plus 2 cos x by 2, and limit is from 0 to pi by 2, plus its integration. In that integration 1 2 means x by 2 by half, that is 2 will be outside, and its limit is minus cos of x by 2 minus sin of x by 2, and limits are from pi by 2 to pi. Now integration is completed. We have to put upper limit and lower limit. In this case, it is equal to 2 into sin x by 2, x is pi by 2, sin x by 2, 1 by root x by 4, plus 2 cos of that means cos of pi by 4 is again 1 by root 2, minus 2 into, this is cos, minus is taken, and cos pi by 2 is 0, then plus sin pi by 2, sin pi by 2 is 1, Then we have to take one minus common, pi by 2. So cos pi by 4, it is 1 by root 2. 2 is there, and this is again pi by root 2, 1 by root 2. So we put all the limits, dual limit, upper limit everywhere. After simplification, it is our answer. And after simplification, the answer will be, I think this, just 1 minute. After simplification, this is our answer. Okay. Next problem. This part you do yourself. Simplification, only that part is left there. So you do it yourself. Next. Next problem is minus a to plus a x e to the power x square plus 1 divided by 1 plus x square dx. Options: tan inverse a, 2 tan inverse a, tan inverse 1 by a, and 2 tan inverse 1 by a. Interval is symmetric. So, as the interval is symmetric, let's see whether it is an odd function or even function. Denominator is even function. This is odd, this is even. So this part is odd function, this is constant, so not odd, not even. So let us try to write it in that way. Minus a to a, this part first, then integration minus a to a dx by 1 plus x square. This is integrable very easily. We can integrate that very easily. And in that case, interval is symmetric. This is odd part, this is even. So this is odd function, this is even function. Ultimately, odd by even is odd function. So integral is odd function, interval is symmetric. So this part vanishes. 0 plus, it is tan inverse. It is actually, you see, it is even function. Now it is even function and interval is symmetric. So we can write it as 2 0 to a dx by 1 plus x square, so that it is equal to 2 tan inverse x from 0 to a, so that it is 2 tan inverse a minus tan inverse 0 is 0. So this is 2 tan inverse a. So option is that. That option is correct. Next problem. Now the next problem is 0 to integrate 0 to 2 mod of x square minus 1 dx. Option is 2, 1, 0 and minus 1. This is again a mod function. So we have to take the integrand outside the mod function in order to integrate that. Now it is actually 0 at x is equal to plus minus 1, but minus 1 is not there. So at x is equal to 1, it becomes 0. So before that, this become negative, and after 1, this become positive. So that I can write it as 0 to 1 mod of x squared minus 1 dx plus 1 to 2 mod of x squared minus 1 dx. It is equal to, now that part, x value of x is 1 or less, so that this become negative, so that this is equal to 0 to 1 1 minus x square dx, and x in that case x is more than 1. So if x is more than 1, that part is positive, so that it is equal to 1 to 2 x square minus 1 dx. Now it is very extremely simple. This is actually integration is x minus x cubed by 3 and limit from 0 to 1 plus x cubed by 3 minus x limit from 1 to 2. Now it is very simple. You put upper limit, lower limit, etc. and simplify, and answer is 2. This. Next problem. Now, the next problem is minus pi to plus pi e to the power sin x by e to the power sin x plus e to the power minus sin x dx. It is given in 2008. Options are 1, 2.5 pi by 2 and pi. So in this case, the in that definite integral, the limits are symmetric. So let us try whether the integral is even or odd. Actually, you see, the function is neither even function nor odd function. So we cannot use the properties. But then how to integrate? Let us break it. Minus pi to 0 e to the power sin x by e to the power sin x plus e to the power minus sin x dx plus It is between 0 to pi, minus pi to 0, then 0 to pi, same function, e to the power sine x dx by e to the power sine x plus e to the power minus sine x dx. Let us suppose that this is I1 plus I2. I1 is this, I2 is that. So if it is I, then I is equal to I1 plus I2. Now in I1, put x is equal to minus y. Let us see what happens. Change of variable dx is equal to minus dy, and change of limit x to y. When x is equal to minus pi, x is equal to minus pi, y is equal to pi. When x is equal to upper limit 0, oh sorry, when x is equal to minus pi, y is equal to plus pi. When x is equal to upper limit 0, y is equal to 0. So that I1 is equal to, limit is when minus pi, it is pi. So pi to 0. Then dx is equal to minus dy. So minus, it is e to the power sine minus x is minus sine x. E to the power sine minus x. Oh, sorry. It is minus. I have put x is equal to minus y. So it is equal to sine of minus y. It is e to the power sine of y plus e to the power sine of minus y. Another negative is there. E to the power sine y dy. Now negative is there, so we can change the limits. It become 0 to pi e to the power minus sine y by e to the power minus sine y plus e to the power sine y dy. Now in any definite integral, so taking the limits unchanged and functional values unchanged, we can take x in y instead of x. That is, we can change variable. So it become 0 to pi e to the power minus sine x by e to the power minus sine x plus e to the power sine x dx. This is our I1. So I is equal to I1 plus I2. I is equal to I1 plus I2. I1 is this, 0 to pi e to the power minus sine x by e to the power sine x, this sine x plus e to the power minus sine x. I write this here plus this is I1, and I2 is this, that is that its denominator are same, limits are same. So it is actually e to the power sine x dx. So sum of these two is that. Now you see, numerator and denominator are same. Oh, just 1 minute. Just 1 minute. I is equal to I1 plus I2. So it is equal to 0 to pi dx, only dx. So it is pi. So I is equal to pi. The value of this is equal to pi. Okay, so answer is this. Next one. Bhajna. Now let us see what is the next problem here. Given that -1 to 4 fx dx is equal to 4. This is -1 to 4 fx dx is, this is also 4. And 2 to 4, 2 into 3 minus fx dx is equal to 7. Then to find -1 to 2 fx dx, how much? That problem is given in the year 2009. Options are 1, 3/2, 0 and 5. Achha. This can be written as, we have to find, okay, it is -1 to 2 fx dx plus 2 to 4 fx dx is equal to 4. I break the interval -1 to 2 and 2 to 4. So suppose this is 1, and given that 7 is equal to 2 to 4 6 dx minus 2 into 2 to 4 fx dx. This is equal to this one, 6 into x. So 6 into 4 minus 2, that is 6 into 2 minus 2 times I want -1 to 2. This is -1 to 2. Oh, no. This is 2 to 4, okay. This is 2 to 4 fx dx. It is equal to, that is 7 is equal to 12 minus 2 into 2 to 4 fx dx. That is, we get 2 to 4 fx dx. This is taken there 5. This is 5. Now put this value in equation number 1. Then we must get, in equation number 1 means this, we get -1 to 2 fx dx plus 2 to 4 fx dx. 2 to 4 fx dx, 2 to 4 fx dx is 5 by 2 is equal to 4. So that minus 1 to 2 fx dx is equal to 3 by 2. So we already get the answer, minus 1 to 2 fx dx, that we want. Minus 1 to 2 fx dx, how much? It is 3 by 2. So our answer is this. Now, next. Next problem. Let I1 is equal to 0 to pi by 4 sine square x dx, and I2 is equal to 0 to pi by 4 cos square x dx, then which one is correct? Number 1, I1 is equal to I2. Number 2, I1 is less than I2. I1 is greater than I2. And number 4 is I1 plus I2 is equal to pi, not pi, pi by 2. Sure. Let us start from there. I2 minus I1. Limits are same. Both are pi by 4. 0 to pi by 4. In I1 is this, I2 is that. So that it is equal to 0 to pi by 4 cos square x minus sine square x dx. This is cos 2x. So this is equal to 0 to pi by 4 cos 2x dx. It is equal to sine 2x, integration is sine 2x by 2, and 0 to pi by 4. Its limit pi by 4 means it is sine pi by 2, that is 1 by 2 minus, then lower limit it becomes 0, minus 0. It is in fact positive. Half minus 0 is positive. So we get I2 minus I1 is positive, so that we get I2 is greater than I1. I2 is greater than I1, so I2 is greater than I1, so this option is correct. This is simple way to calculate. There is another method. That method is like that. That is also very simple. Limit of the intervals, both are same. In that interval, cos square x, that integrand, cos square x is greater than that integrand sine square x. So in that interval, in 0 to pi by 4, cos square x is greater than sine square x. So at every point in that, this ordinate is greater than that ordinate. So very clearly their integration 0 to pi by 4 cos square x dx is greater than 0 to pi by 4 sine square x dx. So I2 is greater than I1. That one, correct. Okay, today is up to this. Next day also I take few more important problems. So today is up to that. Once again I request you, if you feel that this is helpful for you, so please share it, like it, and subscribe my channel. Thank you.